Here's a problem you may have experienced in the past. You're using an app on your phone, and you tap a button. That button is intended to do a bunch of work. Let's say it's going to grab data from the internet, play some music, or do some heavy number crunching to apply a blur effect on some image. Once that button is clicked, though, your program appears frozen for what feels like an uncomfortable amount of time. This is super janky. You're not sure that if the thing has crashed or what. Then after a few moments, suddenly everything comes back under your control. Why did it freeze and then suddenly come back to life like that? More often than not, your app is trying to process something that takes a long time, such as grabbing some information from the internet. The issue is that something like a network request can take a really long time if the internet connection is flaky or if there's a lot of data to transfer. We need to set up the connection with the web server, send the request, wait for a response, and then parse the response. Nothing else can happen on the main thread when you're waiting for this entire round trip to finish. So, if the user clicks other buttons in the app while the network request is happening, the app can't respond to the user until it's finished that network operation. Even worse, if the user angrily taps the button several more times, those events will just get queued up until the app has completed the current task. If you ask the UI thread to process something that could take some time, you run the risk of having your app appear to freeze up when it's being used. Actually, if your app blocks the UI thread for more than a few seconds, Android's going to display a dialog telling you, the user, that your app is unresponsive and ask if the user wants to close it. This brings us to an important rule when building apps in Android. Do not block the main UI thread. Luckily, Android devices are great at multitasking.
Oh yeah?
Yeah. If the user clicks a button, we want the app to be responsive to user input. The solution to this problem is to have the network request, the number crunching, and the audio playback all processing on separate background threads or worker threads, thereby freeing up the UI so that the user can still scroll and tap and do whatever else they need to do with your app while they're waiting for all these other jobs to finish.
Oh, so in theory, you could use as many threads as you need, right? That means more work can be executed in parallel.
Yes, but for this app, we only need a single background thread. The background thread can only do one operation at a time, but if the network request is going to take a really long time because you're on a slow internet connection or it's flaky, then that's okay. The main thread can still handle all the user input events quickly without any impact on the user experience.
Yeah, and one more thing. After the background work is done, then there's no need to keep that thread active. So, in this video, we've learned that your app can split jobs into separate threads to allow certain tasks to be processed in the background while keeping the UI thread clear, which means that you can make the app more usable and faster.